Hi everyone, welcome back to Workshop, and it's repair time again. And no, this is not part 3 of the Keithley 2001 multimeter repair. That one's coming, don't worry. Right now I've got a Rigol DG1022Z. It's an arbitrary waveform function generator, and it's faulty. It was kindly donated by TDV Electronics. They're a bus and truck electronic module repair company, the ECUs, that sort of thing, for engines, body, gearboxes, etc. And this is one of the tools that they use for their repairs, and this one's faulty, and they kindly donated it to the channel, and I'm going to have a look at it today and see if we can effect a repair. So what I was told was that the unit was in operation and they accidentally put 28 volts DC into the outputs, or one of the outputs here, I don't know which one, and it rendered it faulty straight afterwards. Not quite surprising. I don't know what the specifications are, the robustness of these outputs are, but certainly I would have thought that sticking 28 volts DC into the outputs would probably render something on the circuit board inside faulty. So we're going to power it up, we're going to take a quick look at the operation of it, and let's see if we can see anything wrong with the outputs. Okay, so let's power it up. Well, it's powered up okay, no errors on the display or anything like that. So let's try just turning on the outputs and let's see what happens. So output 1, overload protect, the output is off. Let's try that again. You can see at the bottom here we've got channel 1 and channel 2, they're both off at the moment. So if I just try and turn on channel 1, it's coming up with this message, overload protect. Let's try channel 2, and that one's come on. So there certainly looks like there's a problem with channel 1. So the first thing I'm going to do is I'm going to try and reset the unit to the defaults. So I think we go into utility here and set to defaults, restore all instrument settings to factory default. So yes, we'll go ahead and do that. And I heard a click inside, so looks like that's happened. So let's try channel 1 again. Nope, still got the message. Try channel 2. Yep, channel 2's coming on. Whether I've got something on the output, I'm not too sure. I haven't scoped it yet, but certainly we're getting it on here. Okay, I've got the scope hooked up, so I'm going to at least try channel 2 and let's see if that's working. Let's turn it on. And yes, we're getting something on the display there, so that's looking okay. Let me try scoping channel 1. It's off at the moment. Turn off channel 2. There's channel 1. And you see we've got a DC offset there before it actually switched itself off again. So let me just adjust the voltage there and try that again. So it looks like when you turn it on for a fraction of a second, I'm getting like minus 15 volts on the actual output, and that cannot be right. Now the amplitude level of the signal itself is 5 volts. I should be able to take that down, the set amplitude level. So I've turned it down to 1 volt. Let's see what happens now. Yes, it does change that. And it looks like I get the beginnings of a sine wave there. I'll try setting it to a square wave. Yes, the output is working, it's just it's detecting a fault and then turning it off again. I am getting a sine wave or a square wave, whatever I set it to, so there does look to be a problem, maybe a feedback signal somewhere, I don't know, just guessing at this moment. So I think we'll tear it apart, we'll have a look. Perhaps there's something visible we can see, especially since it was a 28 volts DC signal or power supply that was put back into it. So hopefully we should see something on the circuit board. So let's tear it down. And here we are inside the unit, and it looks really nice to service. It's just the PCB is just laid out in front of you, including the power supply here. So we'll go over some of the items in here just to familiarise ourselves with it. I don't have a schematic for this unit, so we'll be winging it a little in terms of the repair. But to start off, we've got one big PCB here, and the first thing that catches your eye when you see it is this bank of regulators here. We've got plus and minus 15 volt and plus and minus 5 volt regulators there with their electrolytic capacitors on the input and probably the output as well. And that looks like the power supply itself here is not providing regulated DC outputs. It's probably providing an unregulated DC output, or multiple supplies there, and hence the regulators are down on the main PCB. If I just tilt it over, you can see we've got a flat flex here. That'll be going off to the LCD in the front. Another flat flex, that'll be for the keypad at the front. We've got a small buzzer there, and then we've got the BNC connectors here, all nicely shrouded even over the top of the PCB there, for the various components next to the BNCs. And you can see that we've got two channels. You've basically got two identical channels. Right down here is one channel, and right down here is the other channel. So the good thing about having two channels, two identical channels, is I can directly compare between the two channels, especially now that I can see we've got a working channel 2 and a faulty channel 1. So the first thing I'm going to do is I'm going to disassemble the front panel from the main unit, just so that I can get in about those components and BNCs at the front of the board there. I did actually start taking the screws out before I realised I didn't need to take them out to get the case off, but looks like I will continue doing that, I think, yeah, in order to get the front panel off. So let me go ahead and do that now. And there we go, we've got the board exposed. Now, one thing I'd like to know is what sort of components we've got on the other side of the board, because I've not removed it from the case as yet, and I don't really want to. So let's take a quick look with my torch on the underside. Now, there are some passives, but there's not a lot down inside there, if you can see that. It looks like everything I'm going to need to touch is probably on the top side. Great stuff. Okay, been doing a little bit of an investigation, so here's what I've got so far. So this is the output channel A, output channel B, and you can see you've got a couple of little filters there, a little wee choke there, a little wee inductor there, a couple of capacitors, etc. So you've got a little wee output filter on both channels there. That's fine, there's no problem there. Then the signal coming back is connected to this output network of relays, etc. and they'll be for switching in and out the various functions, the 50 ohm load, etc. and it's basically identical mirror image on both circuits. And you've got an op amp here, I think that's an op amp anyway, a high current drive op amp that's basically connected to the 50 ohm network here and somehow into the relay circuit, etc. Okay, first things first, I'm going to check the supplies. So we've got the 4 regulators there, so let's just go along them. Plus 5 volts, perfect. Minus 5 volts, perfect. Minus 15 volts, that's fine. Plus 15 volts, that's fine. So quite happy the supplies are okay. And the first thing I did was I actually put the thermal camera onto the PCB just to see if anything's standing out. So let me bring that in now, and let me just let it stabilize there. Now you can see you've got the 4 relays here, you've got another bunch of relays there, and you've got the 50 ohm resistor there for the low impedance mode, I would presume, and you've got it similarly over there, and you've got a high current drive op amp, which I presume is switching in that 50 ohms. Got a little bit of a heat signature there, and that's down here, round about that op amp there, you can see the 4 relays, the 50 ohm network there, and there is that high current drive op amp there. Now it's not finger hot or anything like that. You've got to watch sometimes using the thermal cameras that you're given a range here, and that range can change all the time depending on your maximum minimum, so red doesn't automatically mean burning hot. It's not quite on the op amp there. I think it's down on this component here that's getting warm here. Let me zoom in a little. So there's the op amp there, and there's that component there. Not really sure what it is. It's a tiny package. I'll have to get in there. You could probably see better than me maybe on camera, but it looks like it's getting warm. So let me get my multimeter down onto that component there. It looks like a resistor, to tell you the truth. I've got minus 1.3 volts on one side, 0 volts on the other. Now looking at the same resistor on the other channel, the channel 2, basically 0 volts there and 0 volts there. Now I am in high impedance mode on both channels, so the 50 ohms shouldn't be switched in at all, so I'm definitely seeing a difference there. Now if I go into the op amp itself, I think 2 and 3 are the inputs. If I go into pin 2, minus 1.3 volts, pin 3 is minus 0.7. Well, that's a big difference on an op amp on the inputs itself. That's going to swing the output completely in one direction. And sure enough, looking at the op amp here, the pin 6 actually connects to the first 49 ohm resistor, and you can see it swung right round to the negative rail there. If I do the same on the other channel, channel 2, there's pin 2, there's pin 3, and the outputs on pin 6, which goes here, it's fine. So I think there's a problem round about here somewhere. Okay, so just what's going on around this circuit here with that funny voltages? So I've reverse engineered this part of the circuit here, so let's take a look. So this is the final output here, the BNC. I haven't drawn on that little filter on the output, but that's the BNC there. And then you've got the relay here, and I haven't drawn on its drive. It's obviously coming from the microprocessor somewhere. I'm not too worried about that at the moment. And then this is the signal from the output stages of the circuit coming in here, and this relay basically switches in and out the 50 ohm low impedance drive. And the way it does that is you've got this relay here has got 2 changeover contacts in it. You can see I've drawn it in the non-energize mode. That's in the high impedance mode. So basically the signal comes from the output stages, goes through this contact here, this 2 sides of the relay are joined together, and away out to the BNC. So the 50 ohm circuit is basically out of circuit. And then obviously when it comes into circuit, the 2 contacts switch over, so the signal comes away up through here, through this non-inverting op amp here. You've got the 50 ohm drive, and then back through and out to the BNC. So there's your 50 ohms. And then tapped off of that is a sense circuit. You've got a couple of 31Ks by the looks of it, and a 24K resistor, and a test point, and basically that goes off to an LM339, a comparator, and basically that'll be feedback for the microprocessor that the 50 ohm has been switched in. That's what I'm thinking anyway. But as you saw with the relay in this non-energize mode, fair enough, the signal was getting through here, no problem at all. However, I was getting some weird voltages in comparison to the working channel 2 in and around this op amp here, and of course that was feeding right through to the other side of the 50 ohm and back onto this contact. Although it wasn't going anywhere, I was getting some weird voltages. And what I think's probably happening is those weird voltages are finding its way to the comparator, and that is then feeding back into the microprocessor. So I think when you saw me first demonstrating channel 1, basically you saw for a fraction of a second on the oscilloscope I was getting the sine wave or the square wave, then it was shutting down. The only thing I'm not too keen on here, I'll have to double check my circuit, is that this input to the op-amp here is basically floating when it's in the non-energized state. So unless I'm missing something or missing another resistor down to ground or something like that, I'll have to double check that. And here's the answer. I think the op-amp is a THS3095. It's a single op-amp within the 8-pin package, and it's got a power down mode. Here we go here, pin 8 PD, and when you set that low, the amplifier goes into power down status. And you've also got a ref pin here, which is actually used in conjunction with the power down mode. And here it is. So what I believe's probably happening is that once the Rigol has detected that we're in high impedance mode, to save having this input to the op-amp floating, etc., it just turns off the op-amp. It goes into power down mode. Now I have checked the voltage at pin 8 and it is low, so that op-amp should be in power down mode. And that even adds more weight to me thinking that the op-amp's faulty, because in power down mode I shouldn't be getting any weird voltages on the inputs, etc. Perhaps a test would be to ground TP703 and see what happens when I power up, and see if I can fool the Rigol into thinking there's no problem with the 50 ohm circuit. So let me go and set that up and we'll try that. Okay, I've got a little bit of Kynar hooked up onto TP703, that's this little wire here. So I'm not going to ground it just yet. I'm going to switch on power and verify the problem still exists. Now both channels are set up exactly the same. So let's just turn on channel 2. Yep, that's fine. Channel 2 off again. Channel 1. And you can see it just switches off immediately and I get the error on the display. So now let me ground TP703. I'll just ground it to the chassis, that's 0 volts. And try channel 1 again. Haha! And look at that! It's on! So let me go and hook up the scope and see if we're actually getting an output. And there's the output. The Rigol's set to 1 volt peak to peak, and that's exactly what I'm getting. So let me just disable channel 1. Yep, and back on again. Yep, it's working. So this is where I was grounding it, so therefore I was fooling the comparator into thinking all was well with this circuit here. So my guess is this op-amp's got a problem. I think we'll take a chance and replace that op-amp. The part number on it has been etched off, but I've got a good idea about what to replace it with, so we'll do that. We'll go ahead and do that now and we'll see what happens. Okay, so I've got a couple of op-amps, so let's change out that one I suspect's faulty and see where we go from there. And there you go, you can see the underside of the op-amp there and the small pad to help dissipate the heat from the op-amp given its high current drive. And there's the pads there for the op-amp, and you can see I'm going to have to make sure that I get a good soldered contact between that pad and the underside of the op-amp. So what I'm going to do is I'm going to put some solder paste, just a small amount, just in the centre of that pad there, and then obviously when I reflow it using the heat gun, I will actually make sure I get a good soldered contact there. And there we go, just a little bit of paste. It's surprising how far it will go, so you don't need too much there. So I'll put the IC in place and I'll get it soldered down. And that's the new op-amp in place, all soldered up. I'm able to verify that the paste underneath the IC is reflowed, because the little copper that comes out the side there, it did actually flow just outside and onto that area there, so I can tell it's reflowed. So next thing to do, let me reposition the camera and we'll try a power up. Right, here we go. Power on. And we're on channel 1, so just double check channel 2. Yep, on, off, and channel 1. Yes! Brilliant. Now I've reconfigured so that I just can switch between the two channels. I wouldn't have fallen to that channel 1 and channel 2 on the screen at the same time. So I've reconfigured them so the yellow one's the channel 1. So I'm set up for a sine wave still at the moment, so let's go on to channel 1. Yes, and we've got an output. Now of course I have disconnected that Kynar wire that was down fooling the comparator. That's all gone now. So yes, it looks like it's working. Let me just adjust the frequency. Yeah. Try square wave. Yes, and how about the level? That's 1 volt peak to peak. So let me just set this up. There we go, 1 volt peak to peak on the scope. Let's go to 2 volts. Yes, that's looking good. 5 volt peak to peak. Yes, perfect. So next thing I'm going to do is just going to put the meter on that op amp and let's just make sure that those weird voltages have gone. Meter's hooked up, so let's go into pin 2. Yeah, 0. Pin 3. Of course the op amp is still disabled because I'm in high impedance mode. And pin 6, this is an important one. And yes, 0. Well, it looks like it's working okay. Certainly in the high impedance mode. I don't pretend to know how to use it. I'm sure it's in utilities somewhere for enabling that 50 ohm part of the circuit. But I'll need to go and look into that. But I'm sure it'll be fine. It looks like it was just the op amp that was faulty. So I think what I'll do now is I'll box it back up. I'm not going to bother with the rubber bumper bars because it just doesn't look right up on my shelf there beside all the rest of my equipment. So let me just go and put it back together. Let's put the case on and a quick retest and ready for work in the workshop. Well, there it is. Another instrument for the workshop. Thanks for watching.